So this is a flow chart summarizing the nomenclature that we've talked about. Some people find flowcharts useful. If you find it useful, use it. Some people find them very confusing, then just completely ignore it, right? But just as a review of what we've talked about 3 different kinds of compounds. Ionic compounds, we've got a metal and a nonmetal. Molecular compounds, only nonmetals, and what we've learned how to name is just 2 nonmetals. And then acids, where we have hydrogen and some other things. They're all going to be nonmetals. With the with the ionic compounds, you're going to name the cation, and then whether it needs a Roman numeral or not depends on whether it has other ions. And so the best way, I think, is just to ask yourself, well, is it in group 1A, 2A, 3A, zinc, or silver? Those guys do not need a Roman numeral, so we don't write one. If it's not in that group, then you use a Roman numeral. The Roman numeral is the charge on the ion. Sometimes students mistake it for the number of ions in the formula, but it's the charge. And then we have the base name. For a binary, we just have a single nonmetal, and the ending changes to "ide," but you can also have an oxyanion over here, and those names are memorized. Molecular is what we talked about today. Use a numerical prefix, the name of the first element, a space, and a prefix in the name of the second element with the ending changed to "ide." The acids, we've got binary acids and oxyacids. Oxyacids have oxygen. We'll look at the ate or ite suffix, and that tells us whether it comes from, I'm rewinding in my brain. It's got oxygen, and so if the oxyanion ends in ate, we change that to ic acid, and if it ends in ite, we change it to us acid. The 2 element ones plus hydrocyanic acid use the prefix hydro in front, and then we take that element name and change the ending to ic and add the word acid. So that's a summary of all the inorganic nomenclature.